16. Now, it was there 2 other years previous to that, so you can find other questions on it. But, you know what I mean? You're looking at experiments that haven't been asked for a while, and you're preparing in advance. So a thorough understanding of concentrations of solution for question 1 is necessary. You need to understand things like capital M, molarity, means moles per litre. And you need to know that percentage weight per volume means things like grams per 100 centimetres cubed. Now, if that doesn't mean anything to you, I would strongly advise that you go back and look at what is meant by a concentration of a solution, because in order to do well in question 1, you really have to have that sorted. What else is going to come up in question 1? I'm still on question 1 here on the next page. You need to take time to ensure that you know the different unique or specific questions that go with each experiment. So while, as I said, with the calculations, there's quite a bit in common, while with the use of the equipment is, common from one experiment in question 1 to another, there are always going to be specific questions that are unique to each experiment. So, for example, if you get an iron tablet or an ammonium iron 2 sulfate, they'll ask you, why was sulfuric acid used at 2 different stages in the iron tablet experiment? So we used it first in crushing the tablets. That was the first stage that we used sulfuric acid, when we actually crushed the tablets. And why did we do that? Well, to prevent Fe2 plus, the iron 2 in the tablets, being oxidized to Fe3 plus by oxygen in the air. So that was the first reason. And that's why we used it when crushing the tablets. And then we also added sulfuric acid to the conical flask before each titration. So later on in the experiment, we added more sulfuric acid to the conical flask before each titration. And why did we do that? Well, we did that to make sure, or to ensure, Mn plus 7 in the KMnO4 is fully reduced to Mn plus 2. So it's going to go from purple to colourless, and not to Mn plus 4, which was a brown precipitate. So that is a question that's going to come up in the iron tablet titration question, but it's not going to come up in a bleach question, and it's not going to come up in a vinegar question, because using sulfuric acid at 2 stages of an experiment is unique or specific to your potassium manganate 7 and iron 2 experiments. Now, if they're going to talk to you about bleach or vinegar, well, one of the questions that's specific to both of those is, why did you dilute them before you used them in the experiments? So the reason why is they're too concentrated. And watch that you use the word concentrated, because sometimes what students will say is they're too strong, and strong means something completely different to concentrated. Strong in terms of, we'll say, what you call it, vinegar. Vinegar contains ethanoic acid, and it's not a strong acid, it's a weak acid. So if you say it's too strong, well, you're initially telling something that is not true, because vinegar is weak. Bleach isn't even an acid, so it can't be strong or weak. So we need to have the right vocabulary. So they are too concentrated and would need excessive or large volumes, whichever you like, excessive amounts of reagents, which in the case of vinegar would be sodium hydroxide, or in the case of your bleach, it's going to be sodium thiosulfate to react with the iodine liberated. So that's what we would write if it was bleach, but that's what we would write if it was vinegar. So again, we can't use the exact same sentence, but what we can use is yes, they're both too concentrated, so that's why I dilute them, and that's why we will need excessive amounts of either sodium hydroxide to react with the vinegar or sodium thiosulfate to react with the iodine that was liberated by the bleach. So, the wording of that is going to be very, very important. So how do you get good at question one? You practice it. You look at your questions, even if you're not doing them in school necessarily, you can go home, you have access to the marking schemes, and you can see exactly what is needed in terms of the calculation, in terms of the general procedures, and in terms of what are the questions unique to each experiment. Question 2 is on organic chemistry, and there are 7 experiments, and they're divided into 4 preparations. Preparation of ethene, ethyne, soap, and benzoic acid. And then there are 3 techniques, and the techniques are steam distillation, solvent extraction, steam distillation with solvent extraction, so that's kind of a 2-in-1, chromatography, and then the other one is recrystallization and finding the melting point. So we've 4 preparations and we've 3 techniques. Now again, do you know what I mean? Last year, 2023, ethyne, 2023 was the preparation of ethyne, and it hadn't been up for quite a while, so it is one that we kind of expected. Right? The preparation of ethene, that is mad in terms of it comes up most years. Not always in section A, but most years on the paper, somewhere or other. So that is a preparation that I would definitely, do you know what I mean, look up, because it's there most years. If it's not in section A of the paper, ethene preparation is somewhere in section B. As I said, ethyne came up in 2023. Soap was there about 3 years ago, benzoic acid relatively recently as well. So, they've kind of gone down the preparation route for the last few years. So maybe it's time for our techniques. Maybe it's time to learn about steam distillation, extraction of clove oil from cloves. Or maybe they're going to ask me how to, carry out chromatography using paper chromatography, although you do have the choice of thin layer or column chromatography as well. But you only have to learn one, folks. So I would suggest paper chromatography because it's the easiest one. Do you know what I mean? But that's up to you, whatever you've covered in school. But you can get away, and you only have to learn one. It's not even getting away with it. There's only one form of chromatography. And then recrystallization and finding the melting point, they, have been asked in recent years as well. Now, there is a link between benzoic acid and recrystallization, because when you make benzoic acid, you are making crystals of benzoic acid. So there's a link between those experiments, because when they've asked benzoic acid in the past, they've dragged in the topic of recrystallization in terms of, if you tested your benzoic acid for purity, how would you go about doing it, etc. Right? Or how would you purify the benzoic acid that you prepared in this experiment? Well, you do so by the technique called recrystallization. So there is a link between those. Now, they can mix these experiments up. So you can get, and several times ethene and ethyne came up together. Soap and benzoic acid have always come up on their own. They've never been mixed. But there have been questions where chromatography is part A of question 2 and steam distillation is part B or something like that. So you can't, like with question 1, kind of say to yourself, they're only going to ask me one of those experiments. They can ask you any of them and they can mix them up. And I am going to put in here, which I should have in there, and your diagnostic tests, which is your one for unsaturation, the one for the presence of aldehydes, and the one for carboxylic acid. So there are those diagnostic tests that also appear in question 2, as does then your reaction of ethanoic acid, CH3COOH, with magnesium. So all of those little tests and that little reaction out of ethanoic acid, CH3COOH with magnesium, also comes up in question 2. Now, each of your experiments is different, but I would go through this checklist. So if there's a diagram showing the apparatus, I need to be able to draw it. So any diagram showing the apparatus, I need to be able to draw that. Especially the ethene, ethine, soap, because you've got both reflux and distillation. Benzoic acid preparation happens in a conical flask. There's nothing really that they can ask you to draw there. It's a conical flask sitting on a heating mantle. Do you know what I mean? It's not that complicated, so that would be unlikely. I technically should be able to do steam distillation, even though anytime it's come up, they've given me the, what do you call it, the reaction. And I'd need to do chromatography. So any diagram that goes with that, right, there is a chance that you'll be asked to draw it. And if you look at past papers, you'll see that that is the case. The ones most likely, though, are the ethene, ethine, and soap, to be honest with you. Any balanced equations that are needed. So you need equations to show the preparation of ethene, the preparation of ethine, preparation of soap, and the preparation of benzoic acid. The equation is quite complicated, so I don't see them asking you that. So the equations that I would need to know are those three. So what's involved in preparing ethene, ethanol giving you ethene and water, ethine, calcium dicarbide and water giving you ethine and what's called calcium hydroxide. So you should know those equations. Although there's a good chance they'll be given to you, there have been occasions where you've either had to write them or finish them off. Now, safety procedures is always going to be a case in every experiment. Anything involving safety procedures, including the hazard symbols. So be able to describe or draw, it doesn't have to be perfect, a hazard symbol for an oxidizing agent. So that is a sphere with the flame coming up out of it. Or the hazard symbol for corrosive. So that is a hand with the test tube held over it, and the drips coming out of the test tube are making kind of a hole or a dip in the hand. Right? So our safety procedures. If it's a technique, you need to know the principle involved. So the principle, for example, of steam distillation is that when you have two immiscible liquids together, they have a lower boiling point than either of them on their own. Now, if that is, ringing bells, great. If it's not, folks, anything to do with steam distillation, chromatography and recrystallization, they all, if you look up your textbooks, they all have a principle that you should be able to recite. It's like a definition. You know what I mean? The principle of recrystallization, more solute dissolves in a hot solvent compared to a cold solvent. The chromatography one is a good bit longer, but make sure that you're familiar with those. Now, if there are any calculations involved, so determining a limiting reactant and a percentage yield, that would come up in your preparations. So your preparation of ethene, ethine, soap, or benzoic acid. So working out which reactant runs out first, working out how successful you were, so your percentage yield. They don't always give a calculation in question 2, but it's there, do you know what I mean, often enough to make it something that needs to be prepared in advance. Any tests being carried out, which I've kind of mentioned up here. So are you burning in oxygen? Are you carrying out tests for unsaturation, tests to show the presence of an aldehyde or a carboxylic acid? Observations. You're meant to have carried these experiments out, and while you were doing them, you're supposed to have noticed the physical appearance of the materials used. So if they're solutions, are they colourless or do they have a colour? Do you know what I mean? Do you get effervescence during a reaction, meaning fizzing due to the release of gas? Is there effervescence? Flame colours. So things like when you combust ethene, we get a luminous flame. But when we combust ethine in air, we get a smoky, luminous flame. Now, we don't have to know the flame for everything, just for those two. Colour changes that are happening. So if there are colour changes going to occur, and that would be very much, relevant to the preparation of benzoic acid, because when we prepare benzoic acid, we use potassium manganate 7, which is purple in color. And it goes from purple to brown precipitate to colorless throughout the experiment, from the beginning to the end. So any color changes that are taking place, anything that you can physically notice with your eyes, they can ask you those observations that are going to occur. Again, question 2, like question 1, can be prepared, as I say, within an inch of its life. It's a matter of you, going to the trouble of looking at all the question 1s and all the question 2s that have appeared over the last, now there's 21 years of this syllabus, folks, and while you might not get through all 21 years, it would be a good idea that you do at least 1 year, if not 2 years, of each of the question 1s and 2s. Now, question 3 is usually on one or more of the remaining 12 mandatory experiments, but it has been a second organic experiment on 2 occasions. So can you keep that in mind? Because it's a long time since it's been a second organic. It was 2004 and then about 2011 or something. So it's a long time since it's been 2. And the reason why it can be 2 is because they could ask you question 2 on a preparation and question 3 on a technique. And there's no overlap. So therefore, that's why they're able to get away with asking you 2 organic chemistry experiments. Now, other than that, the most common experiments that would come up here would be rates of reaction. And I would, in my head, be prepared for that for 2024, a rates of reaction experiment. Drawing graphs based on what you call data that's given to us. Because rates of reaction regularly come up in question 3. If I was going to prepare anything for question 3, it would be the rates of reaction experiments, which is the catalyst, presence of a catalyst, concentration, and temperature. So there's only 3 of them: your catalyst, how concentration and temperature affect the rate of a reaction. There's 3 different parts to that. So I would definitely look at a question on each one of those and practice drawing graphs. If it's the water chapter, for question 3, you can get colorimetry and suspended and dissolved solids. Now, if you want to have a look at something on colorimetry, suspended and dissolved solids, something along those lines, look at 2013 question 3. They gave a whole load of data about 4 swimming pools. Do you know what I mean? So I would suggest that you have a look at that. Colorimetry is a technique that you use to get the concentration of free chlorine in swimming pool water. So that's the experiment I'm talking about with colorimetry. Right? So again, hasn't been asked for a while now, 2013, that they asked you the method involved in carrying out colorimetry. It was there as well, I think, 2006. If you want to look at 2006, question 3, also for colorimetry. So not been around for a while, so maybe something worth looking at. The heat of reaction with an acid and a base, folks, that was 2023. So that's the least likely one for you guys. And it hadn't been there for a few years, and we were expecting it in 2023. So thank goodness it turned up. And I would have been in this class this time last year telling them that it was one that would be quite possible. So, but that's now 2023, so it's probably the least likely one for us to appear. Determining the molecular mass of a volatile liquid has come up a few times. So determining using a volatile liquid, using either a gas syringe or your conical flask with the tin foil and the pinhole in it, whichever method you used. Now that's been question 3 quite often. So it's also a good one because you can prepare it for question 3, but it often comes up in section B as well. So if you're preparing it for question 3, you're preparing it also for section B question, a half a question. So I think it's worthwhile every year having a look at that one. And as I said, it hasn't been question 3 in 2023, so it would be one that I would consider. Now your test for anions and your flame tests have come up in question 3 as well. Test for anions and flame tests. A good question to look for this is 2009 question 3. So I'm suggesting questions that you might have a look at. Do you know what I mean? To help prepare for these experiments. And again, you have 5.5 months to do so. So, do you know what I mean? There's no reason, if you're willing to put in a little bit of time and effort, do you know what I mean, to try these questions out. And what I do maybe at this stage of the year to try and kind of get through as much as possible is I would take out the questions. I'd also look at the marking schemes. So I'd go straight question to answer. Do you know what I mean? Because time-wise, you know, that's a great thing to be able to do, you know, during 5th year, start of 6th year, if it is that you're, you know what I mean, you're running low on time and you feel that, you know, there isn't enough time for you to learn everything that you need to learn. I would kind of approach doing my questions that way from this point onwards. Take out the question, have a look at it, see what you're able to do, jot a few points down, but then look at what the answers should have been. And if you're looking at the marking scheme, some of that is going to go into your head. Some of that is. And that's going to kind of be the exact answer with the wording that they're looking for. And that's what I'd be going for. Now, remember, you don't have to do any of those questions at all if you don't want to. But if you leave out those, I think you're mad, because you can have them prepared. And if you prepare even just 2 out of those 3, the first 2, if you got those prepared, which is 15 experiments, only 15, right? And remembering the degree of overlap for question 1, so it's not really 15 completely separate pieces of information. Well, that's 25%. That's a quarter of your paper that you can have ready to go. If you prepare all your experiments, you're on 37.5%. Okay, so if you don't prepare your experiments, if you don't give them enough time, you are now reducing your chances of getting a H1, mainly because you're reducing your possible choice. Because if you get rid of those first 3 questions and don't do them, it means you have to answer the 8 questions in section B. And while there's a little bit of choice, just in questions 4, 10, and 11, so that's good. Choice is always good. You know, if you've reduced the choice by not studying experiments, then I think that's not a great, you know, a great way to approach Leaving Cert Chemistry. And I've been teaching this now for over 30 years, folks. Do you know what I mean? And it really is about preparation in advance. Anybody that has gotten a H1 in Leaving Cert Chemistry, they will tell you, or they tell me, that they have done a lot of this preparation in advance of going in, so that they're not going in hoping that they're prepared. They know that they're prepared for question 1. They know that they're prepared for question 2. Do you know what I mean? They have a set number of questions that they have prepared, and then they can choose the remaining questions. Do you know what I mean? And they'll have plenty of choice to do that. Now, in section B, there are 8 questions, and if you want to do question 4, I have 3 words for you: practice, practice, practice. The only way you do well in question 4 is practicing. People think, question 4 is the short questions. You know, they're short, they're going to be easy. That is not the case. If you read the Chief Examiner's report about question 4, it is not the best answered question on the paper, purely because people don't practice it. Question 4 in the previous syllabus, folks, used to be compulsory. It was question 1, but it was compulsory. And the average grade was somewhere in the low 80s. When they took the compulsory bit off this short questions question, right, in 2002, the average grade dropped by about 20%. It's down in the 60s now. And that has nothing to do with the material that's being asked. It has everything to do with that if you're told it's compulsory, people practice. If you're told it's not compulsory, people don't practice. That's honestly the difference. And you can read your Chief Examiner's report if you want to tell you that, but I've saved you the time and bother. Now, you're always going to have atomic theory, anything from 1 to 4 parts. You're always going to have organic chemistry. Again, that could be anything from 1 to 4 parts. Stoichiometry is usually 1 or 2 parts. There'll be at least 1 definition, but possibly more than 1. You might get acids and bases, so picking out Do you know what I mean? What's an acid according to Bronsted-Lowry, according to Arrhenius? What's a conjugate acid, a conjugate base? And you'll often get questions on water. I can add to that. You could get redox, do you know what I mean, coming up there as well. You know, so again, it's a matter of going through as many question 4s as possible and seeing that, you know, you need to kind of prepare in advance of going into it. Question 5 is always on atomic theory. Always atomic theory. So there's no question about that. It will be atomic theory, and it's usually one of the following topics. It's either got to do with electronegativity and bonding, including shapes. So that aspect, those chapters go together. Atomic radius and ionization energies, they go together. Or your history of the periodic table, history of the atom, and radioactivity. So whatever topic, whatever one of these appears in question 5, right, it won't be in question 10 or 11. But if it's not in question 5, it very likely could be in question 10 or 11. So your question 5 is a full 50-mark atomic theory. On one of these topics, usually on one of these topics. And whatever topic is examined in question 5, they will ask the other topics that weren't examined in question 10 or 11. Question 6, fuels and heats of reaction. So your fuels, this is from organic chemistry, your crude oil, your natural gas, your petrol. So your fuels and heats of reaction is the name of the question. Now, it has been fuels and heats of reaction for 19 years out of 20. And it has been fuels and heats of reaction for the last 17 years. So it's definitely been fuels and heats of reaction for the last 17 years. So they've kind of set a little kind of a precedent here. You know what I mean? So I can't, and I'd be very surprised to see if they changed that. But even if they did, and they didn't go for fuels and heats of reaction in question 6, there's going to be something on fuels and heats of reaction in question 10 or 11. But I am pretty confident that that's going to be your question. So the fuels part, as I said, is your crude oil, your natural gas, and your heats of reaction is your working out heats of combustion and heats of formation using Hess's law. And again, do you know what I mean? There has been a Hess's law calculation every year except 2007. So there's been a Hess's law every single year except for 2007, and that's the exception to the rule. So otherwise, Hess's law is there. And it's a good one to prepare in advance of the exam because, again, it's quite repetitive. If you go through like about 6 or 7 question 6s, you're going to see the same, you know, material begin to repeat itself. And it's also one where, in order to get a whole question, you have very little material to prepare. You know, so in the notes that I give my students, they can get the whole of question 6 by studying just 5 pages of foolscap. 5 pages of foolscap gets them the whole thing. Whereas in order to prepare for question 5, they have 10 handouts. You know, 10 handouts, sorry, 11, because it's including shapes of molecules. They have 11 handouts. They probably, on average, my notes would have at least maybe 12, 13 pages, do you know what I mean, per handout. So you're looking at 100 to 120 pages of material to learn for question 5. For question 6, about 5 pages of material. So you go to your book, you go find your crude oil, your natural gas, your petrol, and you go to your book and you find the calculation involving Hess's law, right, for heats of combustion and heats of formation. And that's a whole question. So it's another one that I would have, what you call it, prepared before going into the exam. Now, question 7, I've missed question 7 here, and it's not that I've missed it, but, you know, question 7, right, we really don't know the topic. It might be acids, bases, pH indicators. So if you look at question 7, every, I don't know, maybe 7 out of every 10 years it's on that topic. We're not 100% sure of it. We're not guaranteed of it, but we know that it's likely to be that topic. Or if it's not on that, it could be equilibrium, chemical equilibrium. If equilibrium is going to be a full question. So equilibrium, question 7, or these. Now, it could be something completely different. It could be a rates of reaction question. I'm just giving you the possibilities. But the thing is, I don't know. But I do know the topics for question 6. So wouldn't I be mad not to learn and go make sure that I'm au fait with these topics on question 6? Rather, well, not so much rather, obviously you want to study everything to get a H1, but you can have this prepared really, really well. This involves a lot more work to do in order to prepare for question 7. Question 8 or question 9, once or twice it's been both, but question 8 or question 9 is what we call our general organic chemistry question. And this is where you need to know how to draw and name all of your organic molecules from your 8 different homologous series. Now that's your alkanes, your alkenes, your alkynes, your alcohols, your aldehydes, your ketones, your carboxylic acids, and your esters. And I'm doing this with my 6th years at the moment. The 6th years that I'm teaching in 1 year. So we started the course in September. We're going to finish it, mid-May. And I'm doing the whole course in 1 year with them. So we're going at quite a fast pace. So I'm nearly halfway through organic chemistry with them. And I was going through questions today in class, and I was showing them, look at how many marks you get for drawing and naming molecules. And look at how many marks you're going to lose if you can't draw and you can't name the molecules. So sitting down and spending time and energy. That's what I keep telling my gang. There is not one person who's sitting leaving cert chemistry that cannot actually draw and name organic molecules if they spend enough time and they put enough energy into it. People go, oh, I can't do it. Of course you can do it. It's time and energy. It's time and sitting down, and it's energy on your part, and it might make you feel awful because you're going, I can't do this, but the more you go at it, you will be able to do it, and you'll feel better as a result. Now, the drawing and naming molecules will allow you to lead on to all the different reaction types. And there are lots of reaction types. We've got things like combustion reactions, free radical substitution reactions, ionic addition reactions, elimination reactions. We have oxidation reactions, reduction reactions. We have condensation reactions. We have polymerization reactions. So there's lots of different reaction types. And again, you're not doing these reaction types in one night, in one class. They will have been spread out over weeks. So I've listed a whole load of them off there. There's more than 10. I can't remember how many exactly I listed off. But, I wouldn't do all of those reaction types in 1 or even 2 classes. That's going to take me hours and hours to get through. So you don't meet all of these reaction types in one go. You meet them bit by bit. So, you introduce this reaction type and you learn that one. And then you introduce the next one, maybe the next class. And you're going to build up on those. Now, there's 2 reaction types that we have to know mechanisms for, and that is free radical substitution and ionic addition. They're not going to ask you a mechanism for any other reaction type, so just those 2. And we have to know the mechanisms and we have to know the evidence. So maybe you've done the mechanism for free radical substitution. That is your initiation, propagation, termination steps. Being able to write those equations, being able to describe what's going on. With ionic addition reactions, you're going to be looking at polarization of the reagent that's adding on, the heterolytic fission of that reagent, the formation of a carbonium ion, and then the formation of the product. So if you've done mechanisms, the words I'm saying will be familiar to you. If you haven't, well, then that's something that you have yet to do. I haven't done it with my 6th years that are doing the course in 1 year yet. I've done it with my other 6th years that I had for 2 years, but not with those yet. So I still have lots of chapters to do, so there's still plenty of time to get through the material. Evidence, sometimes the questions are only on the evidence. They don't want to know about the mechanisms at all. So sometimes the questions are on evidence and evidence only. But again, if I am preparing for my general organic chemistry question, well, this is where I'm going to start. I'm going to know how to draw and name my molecules. I'm going to know the different reaction types, what reagents and conditions are needed to change, one homologous series into another. So for example, if I wanted to go from ethene plus what would give me this product here. So I'd have to look at it and I'd have to go, okay, if I wanted to go from 2 carbons and 4 hydrogens to 2 carbons, 5 hydrogens and a chlorine, well, the reagent would be HCl, hydrogen chloride. Now that would be the reagent. There's no condition for that one. But if I wanted to change ethene into ethane, my reagent would be hydrogen and my condition, would be nickel catalyst 200 degrees Celsius. So, the different reaction types, as I said, you're meeting them, spread out over a long time frame. So you need to maybe get a page and you need to put each reaction type at the top of the page and see what reactions are needed in those. Now, this is question 8 or 9. So if it's question 8, question 9 might be on the topics that didn't come up in question 7. So question 9 might be rates of reaction. Or question 9 might be equilibrium. Do you know what I mean? If this is on acids, bases, pH. So the topics, question 7 and question 9 are kind of interchangeable. Now, if you're doing question 10, you've got 3 parts and you pick 2. If you're doing question 11, there are 4 parts and you pick 2. So that's great. You've got more choice. Now, in questions 10 and 11, there is usually, I expect to get more organic chemistry and more atomic theory. So whatever wasn't asked in the general organic or in the fuels, that can come up in question 10 or 11. Whatever wasn't asked in question 5 for my atomic theory, that can appear in question 10 or 11. This is also where you'll probably get a stoichiometry problem to solve. I was doing stoichiometry problems with my 5th years today. And in the 3 questions that we decided to look at for stoichiometry, it was all question 10 part C. Now that's probably just coincidence, but if there's stoichiometry in question 10, it won't be in one of the parts of question 11 or vice versa. Now you can get any other topic. The parts in question 10 or 11, there's no link between them. They're completely separate. So this allows them to ask you questions on 3 different parts of your syllabus. This allows them to ask you questions on 4 other parts. So question 10 or 11, they're able to cover 7 different aspects of your course. And the good news is within these, chances are you'll see 2 bits out of the 3 or 2 bits out of the 4 that you like. Part D of question 11 will examine the option. Now your teacher will decide which option they're doing, and that's the part of the paper where you're going to find the option. Also, the last part of question 4 is on the option, right? So, but the main part here will be, so the option is only worth 25 marks in question 11. Now, there's usually a full and a half a question minimum on the 3 areas, equilibrium, water, and rates. So after I have prepared my volumetric analysis and my organic and my atomic theory, I'd be going for these 3 chapters. These would be the next chapters of importance, right? So you pick out any Leaving Cert paper, you'll get a full question and a half a question on these. Some years you could get 2 full questions, so 1 on equilibrium, 1 on rates, and a half a question on water. Or you might get a full question on water and a half on rates or a half on equilibrium. But there are 3 chapters. There's only 1 chapter each in your books. So instead of having to learn maybe, 4 or 5 chapters on atomic theory, or 3 or 4 chapters on organic, you only have to learn 1, 1, and 1. So they're kind of self-contained chapters. So they would definitely improve your choice on your paper. So allocation of the marks in the main areas. Now I want you to keep these numbers in mind. Organic chemistry is going to be anything from 150 to 200 marks on your paper. Now that's out of 400. So, leaving out or not putting time and effort into organic chemistry is absolute madness. So let's say it's 150 divided by 400. That means you're looking at anything from 37.5% up to 50% of the paper on organic chemistry. That's your question 2, your question 6, and your question 8 or question 9, and your half a question in question 10 or question 11 on organic. So if you've that many questions on organic, obviously it's going to be a good chunk of the marks. Your atomic theory is question 5, question 10 or question 11, and question 4. So let's say there's one part of question 4 worth 6 marks, question 5 is 50, and question 10 or 11 is worth 25. So that's where I'm getting my 81 out of 400. So that's worth 20.25%. So between organic and atomic theory, it's 70%, folks, possibly 70% of the paper. It's definitely going to give you 60 anyway. Volumetric analysis, which we know is question 1, is 50 marks. So there's 12.5% of your paper. So if you take, let's say 45 for organic, 65, 77, those areas alone will get you a H3. Those areas of the paper. And then if you put in the fact that equilibrium rates or water is going to give you another full question, which is 12.5, and another half question, which is 6.25%. So you're looking at another 18% of your paper. So now you're up in the contention for a H2 and possibly a H1. So, preparing is the thing. Preparation. Giving the topics that are worth most of the marks on the paper a lot of time and energy. So giving those areas. If I were a student who at this point was thinking, how am I going to maximize my marks? How am I going to get through this? And, you can do this on your own with your marking schemes. So, some people will say to me, oh, my teacher doesn't do exam questions. Well, that's terrible, but you can do exam questions. You can take out the exam papers. It mightn't be something that you, feel very happy about, but it is something that you could do. You can do, all of that. So that's kind of the layout of the paper. They're the areas that you can actually prepare in advance. Does anybody have any questions that they want to ask me? You can put on your microphones and ask me, or you can, you can type into the chat and ask me. Anybody in particular, anything they want to ask? No? You're a quiet bunch then. Nothing? Okay, folks. Well, if we have no questions, all right, to ask, then that kind of is, everything that you might need to know in order to maximize your grades. Somebody has their hand up. Good. Louis, off you go.
Oh yeah, sorry, can you hear me?
Yeah, can, of course, yeah.
Yeah. How, what do you reckon the best way to go about organic chemistry would be?
Well, I'd start
Revision.
with, yeah, I'd start with taking out my piece of paper and practicing drawing and naming alkanes, and then I'd move on to alkenes, and then I'd move on to alkynes, and I'd go through all of those. Because if you can't draw and name the molecules, you're really going to be at a loss when it comes to, do you know what I mean, to doing to doing equations. So start with drawing and naming first of all, right? The other, that would be for your general organic chemistry question. And once I can draw and name them, I'd move on to the different reaction types. You know what I mean? So I'd go back to alkanes. Now that I can draw and name them, what reactions am I going to have to know for alkanes? And that's going to be free radical substitution, right? And then what you're going to do is you're going to see how do I draw or how do I write one of those equations, you know? And if you're doing a free radical substitution reaction, so hopefully you can see my screen there. So you're going to take
Yeah.
methane, right? So there's methane, I can draw it. And the only reagent that they can ask you to react an alkane with is chlorine on the leave insert. There's only one reagent for a free radical substitution reaction. And what you're going to do is you're going to substitute one of these four H's, just one, with one of these chlorines, because it's a substitution. So you're replacing one of the H's with a chlorine. So let's say I did this one. Now, they don't mind what one you do, but I took this H off and I put one of those chlorines on here instead. Now, the H that I took off, that can't disappear into thin air. And the Cl atom that's left over from this chlorine molecule, that can't disappear into thin air either. So they form the second product of that reaction. And this needs ultraviolet light or it won't happen. So you see, there's my free radical substitution reaction. Do you get me?
I do, yeah. Thank
Yeah,
you.
if I'm doing an elimination reaction, so for the preparation of ethene, so I start with ethanol. Now, the word they use is elimination, and to eliminate something means to take it away, to remove something. So we're going to remove a small molecule from ethanol, and I'm just circled. They're the things I'm removing. So that's water when you take it away. Two H's and an O. So that's a small molecule that was eliminated, was taken away from a larger molecule. Now look at what's left over. 2 carbons, 4 hydrogens. Now if you've 2 carbons and 4 hydrogens, because that's all that's left over, 2 C's and 1, 2, 3, 4, a double bond has to form in between them. And there you use your aluminium oxide and heat. So I would be going through, you know, that's for alkanes, that's for alcohols, you know, and they will list which reactions, do you know what I mean, you're going to have. That's how I prepare for my general question. How do I prepare for my experiment? I look at every experiment question that has come up in question 2. So my 4 preparations and my, what you call it, my techniques that I was talking about there earlier on. You know, I mean, they've asked every one of those already. It's not like they haven't asked any of them. They've asked them all at least once, if not more than once already. So if you look at the chromatography question from 2005, and you look at the chromatography question from 2008, in 2005 it was part of question 10 or 11, in 2008 or is it 2006, it's one of those, yeah, no, it must be 2008 because 2006 would have been too soon afterwards. It's part of question 3, and they've asked you the same question each time. You know, so what are they going to do if they ask chromatography in 20, do you know what I mean, 24? They're going to ask you what's the principle of chromatography, and they're going to ask you to describe how you carried out, do you know what I mean, chromatography. So I would go back to those past paper questions at this point. At this point, if you're in 5th year now, I tell you go off and learn everything. But at this
I'm in
point,
5th year, yeah.
you are? Okay, yeah. So
Yeah.
in 5th year, I'll tell you do that anyway. And if you're doing that in 5th year, Louis, well, you are way ahead of the, do you know what I mean, the gang when it comes to this time next year. Do you know? So there's quite a few people in here who are in 6th year. Do you know what I mean? So you guys, I would be going do you know what I mean, to marking schemes. I mean, I'm telling my fifth years, Louis, about marking schemes since the very, very first day I meet them. You're there and you don't know the answer to a question, and rather than sit around and go, oh, woe is me, I don't know the answer to that question, you know what I mean, and I don't have chemistry tomorrow or whatever, so I can't find that out. Of course you can. You have Google, and you look up your examinations.ie, and you look up the answer to it, and you think about, why is that the answer to that question? And if you don't understand, that's the time to go ask somebody. But if you do understand, well, you're far more likely to remember that because you looked it up rather than me tell you. Do you know what I mean? Right? So when you go to the bother yourself, you're more likely to. So that's how I'd go about organic. I don't know though in fifth year how much organic you'll do. Some teachers do a lot in fifth year, others don't. But do you know what I mean? That's how I would approach it, Louis. Is that okay?
Yeah, thank you.
No problem. Anybody, anything else? Anything you want to ask? So, Jack, where are we going? Let's just have a look here at the questions. If you're picking chemistry for fifth year in TY, what topics do you recommend to study first? Well, you'll start with the periodic table, Jack, would be my thing, right? Because your periodic table is going to be the basis for all chemistry. So I always start on the periodic table. I start with what elements are metals, what elements are non-metals, writing formulas so that I can write equations. So atomic theory is the topic that you would start with, okay? And Kate, is question 3 is an experiment likely to come up 2 years in a row? They've never, Kate, in question 1, 2 or 3, given the same experiment 2 years in a row, ever. Right? There's always been a gap of more, do you know what I mean, than that. Now, 3 years of a gap is possible, but I have never ever seen the same experiment come up in questions 1, 2, and 3, 2 years in a row. Now, if you're going for a H1, you need to know all your experiments, but that's kind of a general rule. Whatever one came up in 2023 goes to the bottom of the pile for your volumetric, your organic, and your question 3. Do you know what I mean, for 2024? Doesn't stop some of those from appearing in section B, but it won't be a full question. Do you know what I mean, experiment-wise? So I hope that answers that question for you. Anything else, folks? No? We're good? Okay, all right. So I hope that was helpful, and thanks for tuning in, and best of luck, and I might see some of you in the evenings, or I might in the evening classes on a Tuesday. I do those, or maybe over February midterm or Easter, I'll be doing courses as well. Okay, so if you've any interest in that, I can see you again. So thanks a million, guys. Have a great evening, and hopefully that was good for you. Thank you. Bye bye.
Thank you.
You're very welcome. You're very welcome, and thank you.
Cheers, Miss.
Bye bye. Thank you. Bye.
Thank you.
Bye.